All right, welcome to today's math class. We tried to go online the other day and we had a network issue, but today we try to do it again. So we still try to do a test run on, going live on our channel. So we have an exponential challenge before us here. The question is 5 to the power of x plus 1 equal to 2 to the power of 3x. What then is the value of x that will actually satisfy this exponential equation? Although this is not a tough one, it's a very simple one, but we'll try to, get the perfect system for our live videos. Okay, so how do we solve this? We're going to take our challenge here, our solution first. All right, now, if you look at this, check out the exponent. We just have to rewrite the exponent on the left-hand side of the equation. So this could be written as our 5 to the power of x times 5 to the power of 1 equal to 2 to the power of 3x. We just apply a law in indices which says that your a raised to the power of mn, this is same thing as a to the power of your m or raised to the power of your n. Okay, so if we apply that law, then we're going to have this back here. Okay, sorry, no, this law, sorry. Oh, so if you have your a to the power of your m plus n, this is same thing as a to the power of your m times your a to the power of your n. Okay, so since the base numbers are the same, then we can add the exponent. Okay, so that's why this could be written in this format. Okay, so if we have this to be so, let me erase this. So if we have this to be so, then we divide by 5 to the power of x in order to carry all the terms having variable to one side. So this leave the system. We now have our 5 is equal to our 2 to the power of 3x all over 5 to the power of x. Look at this. I want to rewrite this power here. This could be written applying the law of indices, which says that if you have your a to the power of your mn, this is equal to your a to the power of your m or raised to the power of your n. So I want to separate these two powers here. And so we're going to have our 5 equal to 2 to the power of 3, close bracket, or raised to the power of x, all over 5, or raised to the power of x. Simple, right? Now look at the power at the denominator and the power at the numerator. They are the same. So again, we apply the rule which says that your a to the power of your m all over your a to the power of your m, this is equal to, okay, so let's take this to be b, okay, b to the power of your m. Oh, what is happening to this chart here? So b to the power of your m, then this is a all over b all raised to the power of m. So if we apply that, we can write this as our 5 is equal to our 2 to the power of 3 all over 5 all raised to the power of our x here. Okay, so with this, what we do, let's just quickly arrange and bring this to this other side. Then take this to this side. This is going to give us our 2 to the power of 3 all over 5 all raised to the power of our x. This is equal to R5. So what we do here is just to either ln both sides of the equation or we take log to base 10 on both sides of the equation. So from here, let's take log to base 10. So we're going to have log to our 3 to the power 2 to the power of 3 all over 5 all raised to the power of x is equal to the log of 5 or in base 10. This is also base 10. So apply the law of logarithm, which says that your if you have log, let's take log your x to the power of a, this is same thing as your a times your log x. So we want to move this power to this side of the equation. So this is going to give us our x times the log of 2 to the power of 3 all over 5 or in base 10. This is equal to the log of R5 base 10. Simple, right? So we are looking for S. So it is easy for us now. Let's divide through by log our 2 to the power of 3, then all over 5 or in base 10. Then equally divide this by log 2 to the power of 3 all over 5 or in base 10. So this and this will leave the system. We're now left with our x will now be equal to, here we're going to apply the division law of logarithm again. So what does it say? It says that the division law of logarithm says that when you have your log, let's take your a, okay, a all over b, then this could be written as your log, your a minus log, your b, all in base 10. Okay, so if we do that, we're going to have our x will now be equal to our log 5 all over your log 2 to the power of 3 base 10 minus log 5 base 10. Okay, so with what we have in here, what we do, it is simple. We apply the law of logarithm again, which is the power law of logarithm. So applying that is going to give us our x will now be equal to log our 5 all over, just going to give us 3 times log 2 base 10, then minus our log 5 base 10. Okay, so with this, we can get the numerical value for our x. We can impute this in our calculator, impute this in our calculator, impute this in our calculator, and when you simplify, you have a numerical value to this. Okay, so this is the final value of x that actually satisfy these exponential equation here. Okay, so we'll be doing more of life, okay, as far as this channel is concerned, provided we get the perfect way of going live. Okay, so thank you. You have any question with regards to this challenge, drop it in the comment section. I'm going to meet you up there. See you in our next class. Till then, keep winning. Bye for now.